So up on the board here I've got a couple of prisms. The first one on the left is called a rectangular prism. And the one on the right here is a triangular prism. Typically, a prism is described by its base, what shape its base is. And when you're looking at a prism, you're looking for a three-dimensional shape that has some two-dimensional geometric figure as a base and its identical twin some distance away from it. So if you look at this rectangular prism, it could be the bottom and the top are the same, the right and the left are the same, or the front and the back are the same. You have all kinds of choices for bases here. Just for continuity of everything else, let's just say the bottom and the top are the base on a rectangular prism, just so we're doing them consistently the same as each other. There's a specialized formula for the volume of a rectangular prism. The specialized formula is length times width times height. Okay, specialized formulas are all well and good, but that only works on a rectangular prism. It doesn't work on any other prism. So we can generalize this formula by considering what we're looking at here with the rectangular prism. If I'm establishing that this rectangle down the bottom here is the base, what is the area of that rectangle? The area of this black rectangle? Length times width, right? It's just a rectangle, length times width. Notice, length times width is right there, and the base itself is being raised up that high, the perpendicular height here, and that's how volume is found out. You find the area of the base, you multiply by the height. That's the general formula for all prisms. So this is specifically for rectangular prisms. For all prisms, volume is equal to area of base times height, where B is area of base. So what I want you to do on these problems is I want you to establish what the base is, find its area, and then the height is how far apart the bases sit from each other. So in this triangular prism over here, the triangle is the base, because if you look at this triangle right here, its identical twin is over there. So this is our base, and the distance between the two bases is this dimension here. That's the height. Okay, so height doesn't always have to be up and down. It could be left and right, whatever. All right? You find the base, you find the other base, how far apart are those bases? That's what height is for the sake of this formula. So if this is the problem, I want to find the area of this triangle, that's B. I want to find the distance between the bases, that's H. And once I find both those numbers, I simply multiply them together to find the volume of it. Unit on volume is always cubic, so if it's feet, it's cubic feet, inches, cubic inches. You do want to make sure all the dimensions are the same unit, so if they throw feet and inches in the same problem, modify either feet to inches, inches to feet, so it's all the same unit. Okay, that's the main idea of how to do a prism if it's a right or oblique prism. So you'll see example 1, there's example 1 and 1A. This is a right prism where the height's straight up and down. This is an oblique prism where the height is, the slant height is slanted, so there's a perpendicular height as well. I don't know why that's there. So, right here, this represents what you do your homework. You make your little boxes for your homework, and you do your problems right, and you show all your work, and you write your answer. And there's some of you who don't think that showing work is the least bit important whatsoever, and I'm done with that. Okay, that is flat out lazy. I'm done with it. Not a single person in this classroom impresses me by doing everything in their head. I can do everything in my head too. I don't care. What impresses me, what shows me that you understand completely what's going on, is that you can go from the problem presented, show all of your work in order to create the answer. That's what impresses me. That shows me that you have a complete understanding of the material. Not just, I'm pretty sure I'm supposed to multiply these numbers, and maybe I'm supposed to add that one. Oh, and that's the answer, and then maybe I got it right. And I have no earthly idea where that answer came from. If it's wrong, neither do you. Okay, so show your work. That box represents your homework paper. a box in your homework paper. What shows up in that box needs to show up on your paper. If you don't show everything I put in this box on your paper, I'm not going to give you full credit for the problem. So here's what's going to happen. Dealing with three-dimensional figures, first thing I'm going to point out is it's hard to draw three-dimensional figures. So I'm not going to make you draw three-dimensional figures. What I want you to do is I want you on your paper to draw a picture of the base. This is a rectangular solid. The base, again, I'm just going to say for all rectangular solids, let's pretend the bottom is the base always. So the base is a 5 by 4 rectangle. So the first thing I'm going to do on my paper is I'm going to put in on my paper a 5 foot by 4 foot rectangle. That is priority 1 on doing a volume or surface area problem. Draw the base. The base is some geometric two-dimensional shape that has some formula that you've already learned. We've done rectangles, triangles, circles, semicircles, squares, trapezoids, all kinds of figures, right? We've got all these two-dimensional figures, had all these formulas. What's the area formula for rectangle? Length times width. So the area, I'm going to call it B, is the length 5 times the width 4, which equals 20 square feet. Notice it's 5 feet and 4 feet. When you multiply the two units, feet makes feet squared. Okay. Once you've drawn the two-dimensional base and you've established the area of that two-dimensional base, then you refer back to the picture and ask yourself, how far away is the other base that matches that? So there's a 5 by 4 base on the bottom. There's a 5 by 4 base on the top. How far apart are they? 1.2 feet. The height is how far apart the bases are from one another. So again, if you visualize on the picture what the base is, there's the same base. How far apart are they? That's what h equals. Okay, notice the base unit is square feet, the height unit is feet. Area of the base is always a square unit because it's an area, and the height is just a unit of length because it's just a length. The volume equals B times H. Then you simply multiply the numbers together. 20 times 1.2 is 24. Feet squared times feet to the first makes feet to the third power. So that's what I expect your homework paper to look like on these problems. I want to see a picture of the base. I want to see where you evaluated B and H, and I want to see where you evaluated the volume from those two numbers. Okay, every piece has to be in there. If you wrote neatly and as organized as possible, that would be beneficial to you as a math student as well. Math is very organized. The neater you can write, the better you're going to understand things. Okay, moving along to example 1A, same idea. We have a oblique prism. Okay, a right prism is a prism that sits straight up. An oblique prism slants. Okay. The volume formula for an oblique prism oblique means slanted. The volume formula for an oblique prism is this. Volume is equal to the area of the base times the height. Does that look familiar? Does the shape look the same? It's slanted, right? But for the most part, it's similar. Okay, there are two heights to look at on an oblique prism. You have the slant height. That's the height from the edge of the base along the edge to the other corner. So from there to there, that's the slant height. Then you have the perpendicular height. That's how far it is straight up or down from base 1 to base 2. This is the height we're looking for. Perpendicular height is that big H that we're looking for over there. And B is the area of the base, just like it was on the last problem. So again, this is an oblique prism. It says find the volume of the oblique prism. Step 1, draw a picture of the base that you're going to use as the base. Again, for the sake of being consistent, I'm going to say the base is simply the bottom of this figure. Again, with rectangular solids, I have the option of picking a base. I could have gone front and back, left and right. I'm going bottom, top. Okay, so for rectangular solid, bottom, top. Any other solid, triangular prism, you have to pick the triangle. Pentagonal prism, you got to pick the pentagon. Hexagonal prism, you got to pick the hexagon. All right, there's no options there, but for a rectangle, you have choices, pick bottom and top, it's easy. So the base is 5 by 4, the area of the base is 5 feet times 4 feet, which is 20 square feet. The perpendicular height of the solid, 1.2 feet. Volume equals the area of the base times the height. So 24 cubic feet is the volume of the oblique prism.
So nothing changes at all?
What?
So nothing changed?
Nothing changed. You just have to be careful that you use the right height. If they give you both the slant height and the perpendicular height, make sure you choose the perpendicular height.